So we're going to do chapter 1, which is problem solving. And today I'm going to be teaching you um, section 1.1, which is inductive and deductive reasoning. So that's what I'm doing today, section 1.1, which is inductive and deductive reasoning. All right? So guys didn't fit on the top, so I had to rewrite that at the bottom. Inductive and deductive reasoning. Okay? So what is inductive reasoning? Inductive reasoning is when you reach a conclusion or reasoning, when you're reasoning, and it's based on patterns. Okay? So any kind of reasoning that's based on patterns is called inductive reasoning. Okay? In this reasoning, you basically decide the pattern in the given data, right, to figure out the next value. So basically, to reach conclusion, you're looking at the data, how it's going, and then you make a conclusion based on that, and that conclusion is called a conjecture. Now this conjecture can be either true or false. So it's not necessarily always true. It may or may not be true. All right. So that's called a conjecture. So the conclusion, another name for conclusion is conjecture. Okay. So remember, as you were growing up in elementary school or in middle school or even in beginning of high school, you were given some kind of data and you used to predict a number based on the pattern, right? So that's that pattern which is based on the previous numbers, right? So that is called inductive reasoning. All right, so that whole thing is called inductive reasoning. Okay, so let us do some examples just to kind of get a hang of it, like what exactly happens when we need to use inductive reasoning. So what actually happens? All right, so we're going to predict the next term in the following patterns. Okay, so some examples to just show how it's done. Okay, so here is a pattern: is 3, 6, 9, 12, 15, blah blah blah. Okay, now you need to figure out what is the next one term. All right, as you can see, there is a difference of what number? Difference of 3, right? Because 3 plus 3 is 6, plus 3 is 9. So between any two consecutive numbers, the difference of 3. All right. So which tells us that the next number is what's the next number? The next number is 18, right? So that's how it goes, okay? So let's do again one more example. So we need to predict again the next number. Now at this time, if you see, you have 1, 3, 6, 10, 8, 15, and that's how and you have to see what this pattern is. So 1 plus what is 3? 2, right? 3 plus what is 6? 3. 6 plus what is 10? 4. Then so on and so forth. So what is the next one? So the answer is, what do you think? 1 plus 2 plus 3, 4, 5 should be, how much do I add to 15? The answer is what? As you can see, there's a difference of 2, and then there's a difference of 3, and then you have a difference of 4, and then you have a difference of 5. So the next should be the difference of 6, right? So the answer is, so the next answer, the next number is what? 21. Great. All right. So what is a counterexample? That's the next topic here. So a counterexample is for any statement, or any conjecture that we make based on the pattern, right? It's now, if it's true in all the cases. Okay, it has to be true in all the cases. Now, a counterexample is that one example when the conjecture is false. So if we can find one example that the conjecture is false, then that statement is not true. Okay, so one example is sufficient to say that the conjecture is false. All right. So basically, if you think about, if I say, let's say I say, if it rains, then I need to be indoors. And one day it's raining, but I'm outdoors. So it's basically, I'm going to say, okay, I was outdoors, it was raining. So that means my statement that if it rains, I stay indoors is false, right? Because at one point I was not at home, or I was out when it was raining, okay? And that was like a planned decision. It was raining and I went out. So that statement is false because you could find one counterexample, okay? So let's do some kind of examples here, just kind of discuss this. So we're going to do mathematical examples, okay? So let's see, if I say that absolute value of x is greater than 0, like is always greater than 0, is that always going to be true? Now think about it. Absolute value of x. Absolute value means if x is negative, absolute value is going to be positive. If x is negative, it's still going to be positive. Now, at what value of x is absolute value of x not greater than 0? So the answer would be, if you think about it, the answer is, if x equal to 0, it's not going to be true, right? If x is 0, then absolute value of x will not be greater than 0, right? So that's the counterexample, okay? So in this case, when x is 0, then the absolute value of x will be 0, right? And because it's 0, that means x equal to 0 is a counterexample. Okay? So that's how, if this statement is not going to be true. Why? Because we could find one counterexample. All right? That's how it goes. Okay? All right. Okay, it's something, it just didn't work here. So I had to kind of retype it here. All right, perfect now. All right, so now let's do another one. So if I say that a square of x is bigger than x, is this conjecture, is this statement always going to be true? Okay, so now if x squared bigger than x, is that always going to be true? So you're going to think about it, right? So you're going to say, what happens when x equal to 1? Is 1 square, which is equal to 1, is this bigger than 1? Is 1 square, which is 1, bigger than 1? So the answer is no, right? 1 is equal to 1. It's not bigger than 1, right? So that means our conjecture is false, because for the value of x equal to 1, it's not true. Okay? All right. So now we're kind of reiterating that. So if x equal to 1, that's the counterexample, and that makes the statement false, right? So that's a counterexample. Let's do one last one here. Square root of x squared is equal to x. Is this going to be always true? So what if, think about it, what if x is a negative number? Then when you do the square of a negative number, so when you do, let's say, x, let's say negative 3. So when you square it, you get 9, right? And then you square root it. Okay, in this case, if it's negative 5, let's say. So if you do negative 5 squared, which is 5, right? Now, is 5 equal to negative 5? No, right? So that means the conjecture that they had is false. Why? Because that x being any negative value, it is not going to be true, right? So if x equal to negative 5 is a counterexample. Okay? So absolute value, square root of, keep saying absolute value, square root of x squared equal to x is not going to be true always. Okay? Okay. Now let's see remember in this section I said deductive reasoning also. I said inductive and deductive reasoning. So what is deductive reasoning? So deductive reasoning is when you base your conclusion, right? When you make a conclusion, it is not based on pattern, but it's based on procedures or facts or information. So it's not a pattern. It's not like something that you see and you say, okay, that works because it's been happening, but it's something that you use your knowledge, or you use your set of information that you have and stuff like that. So basically principles and procedures and knowledge. So that's called deductive reasoning. Okay, so let's do some example here. Let's say one example. Okay, so deductive reasoning is, let's say I give you, say students, can you use deductive reasoning? So use your reasoning based on knowledge or procedures and principles to show that if you do a calculation, so if you do an expression, so if you have so they're giving us a procedure, and they're saying that is this procedure going to produce a number that is 4 times the given number. Okay, the original number that's given to you. So let's see how that goes. So they give us a procedure. So let's say a procedure is, so they're giving us some steps. Pick a number. So let's say you pick a number, let's say x. And then they say multiply by, example, 8. They said that. And they're saying add 6 to the product. So A10 plus 6, right? And then they are saying divide by 2. So A10 plus 6 divided by 2. So that will give you what? When you do A10 divided by 2, you get 4n plus 3. Then subtract 3. So you're subtracting 3 from the expression. So that's going to give you 4n plus 3 minus 3. So in the end, you're going to get 4n, right? So did the procedure bring back the original number? Yes, it did, right? So this whole procedure, then when you do this process and it makes that whole thing work, that's called deductive reasoning, okay? All right, so that's the lesson, section 1.1. There's one more topic, which is puzzles, which I'm going to do next time, which is going to be in the next lesson, okay?